All right, today's lesson is on probability and the addition rule. Now, you know more than you think you know about probability. Very simple example. What's the probability of rolling a 2 on a 6-sided die? Well, there's only one 2, so it's 1 out of 6. So the probability is always the number of outcomes in an event. Like my example, 2 is the outcome, divided by the number of outcomes in the sample space. Sample space is you can get a 1, a 2, a 3, a 4, a 5, or a 6. But think of it this way, it's just the total. So favorable outcomes over the total. All right, so let's start with some probability on a 12-sided die. You know why they call it a 12-sided die? Because there's 12 sides to it. And they have the numbers 1 through 12. Now, to answer some of these questions, or all of these questions, it'll make sense to fill out this little Venn diagram. Remember, I always like to start in the middle. Well, event A is rolling an odd number, 1, 3, 5, 7, 9, or 11. And event B is rolling a number greater than 7. Well, the first thing I want to do is how many odd numbers are greater than 7? 9 is greater than 7, and 11 is greater than 7, and they're odd. The other odd numbers, 1, 3, 5, 7. Now you notice this circle A has all the odd numbers between 1 and 12. 1, 3, 5, 7, 9, 11. Event B again was rolling a number greater than 7. So that would be 8, 9, it's already in the circle, 10, 11 is already in the circle, and 12. So notice there are some numbers missing. I have 1, I don't have 2. I have 3, I don't have 4. I have 5, I don't have 6. I have 7, I have 8, I have 9, I have 10, 11, and 12. So this represents the sample space, the numbers 1 through 12. So first example, what is the probability of set A? Or in other words, what's the probability of getting an odd number? Well, there are 1, 2, 3, 4, 5, 6 outcomes in that event A. So that'd be 6. And over the number of outcomes in the sample space, there were 12 of them. Always reduce your fraction. That's 1/2. So 1/2 is an answer, but so is 0.5. And so is 50%. So we have a 50% chance of rolling an odd number, which makes sense. Now I'm going to show you something you can do on this one. Remember, that's the complement or not in. Another way you can do this is 1 minus the probability of B. They mean the same thing because not in is always out of 1, so not in would be 1 minus the probability of what's in B. So I can always do it this way, so it'd be 1 minus probability of B, 1, 2, 3, 4, 5 of them, out of a total of 12. This is 12 twelfths minus 5 twelfths is 7 twelfths. You can change that to a decimal, you can change that to a percent, but that's fine. So a nice thing to remember is this right here for complement. All right, the intersection, remember this symbol means intersection. The intersection is what they have in common, and notice there are 2 of them, so it'd be 2 out of 12, or 1/6. Again, you can change that to a decimal, which is 0.16 repeated, or 16.6%. Same thing. The union, that's what that symbol means, union. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are in the union. So basically what that means is probability of getting an odd number or a number greater than 7. There's 9 of them that fit in that event. And that can be reduced to 3/4, which is 0.75 or 75%. The next one, this is also an intersection. All right, so an intersection of A intersects not B. here, let me show you what A is. A, sometimes I like to just cover it up. There's A. And then it says the intersection with not B. So here's another way. Remember I showed you this with the circles. Here's A. Intersection is common. Right? What's common to both sets? Not B. This is not in B. Well, these three are not in B. And these are not in B. Again, an intersection is what they have in common, or the overlap. Now you notice 1, 2, 3, 4 were circled twice. So 4 out of 12, or 1/3, is the probability of that event happening. All right, let's see if we can do that same thing with this last one. Like this, just circle over, intersection is an overlap. A union would be anything that's circled if you want to do it that way. So, not in A. This is not in A. These 5, these 6 are not in A. Again, that's intersection, so overlap or what they have in common. Not in B. These are not in B. And again, intersection would be the ones that occur in both sets. Ones that occur in both sets are the ones that are circled twice. And I notice there are 1, 2, 3 that are circled twice. So that would be 1/4. Again, you can change that to a decimal. It's 0.25 or 25%. All right. Now, for your homework, you're going to have to finish all of these problems, even the ones I do. So I'm going to introduce here what's called the addition rule, and there's a formula for the addition rule. It's this one right here. And this is the probability of A union B, which is the word or. So the probability of A happening or the probability of B happening. Now, if there's an overlap, we have to subtract that overlap because I can't count it twice. Okay? If it's in here and in here, it's in both. I've counted it here and here. I have to subtract the overlap. All right, let's go down to this problem right here. You're going to do 3 and 4 and the rest of them on your own. But I want to look at number 5. One of the best ways to do these problems is to make that Venn diagram. So I'm going to make my Venn diagram. And in this problem, I'm dealing with students that own a MacBook, an HP, or both. But I always like to start in the middle. How many of them own both? Well, 10% said they own both. 0.10. Now, if 65% own a MacBook, well, I already have 10% here, so this would be 55% or 0.55. 35 own an HP. Well, I already have 10 in that circle, so I need another 25. Now, if you add these up, 55 and 10 is 65 plus 25 is 90%. That's not 100%, so 10% don't own any of those. All right, so on this first one, what is the probability that a randomly selected student does not own a MacBook? Now that would look like this. Does not own a MacBook. What's the probability? Well, you can use this little picture here to help you. You'll see that do not own a MacBook would be these two right here. So 0.25 plus 0.10, which would be 0.35 or 35% don't own a MacBook. Now remember what I said earlier on the front. This right here is the same thing as 1 minus the probability of the event B happening. And if I did it that way, it would be 1 minus, we know that's 65, so 0.65 would equal 0.35 or 35%. That's exactly what I had. What is the probability that a randomly selected student owns a MacBook but does not own an HP? So probability of owns a MacBook but does not own an HP. Now, if you can just look at these pictures sometimes if you want to. Probability that owns a MacBook, but not an HP. Well, right there. Okay, they own a Mac. These people own a MacBook, but 10% of them own an HP. So that answer would just be 0.55. So this is going to equal 0.55, or 55% probability that a randomly selected person owns a MacBook, but not an HP. All right, next one. What is the probability that a random selected student owns a MacBook? Or, there's that word or. That's my addition rule, so I'm going to show you on that one. They own a MacBook, or, that's a union, an HP. Okay, so in my formula, that's the probability of a MacBook plus the probability of an HP, but because there's an overlap and some own both, I have to subtract that overlap, which is the intersection. So MacBook intersect HP. So how many own a MacBook? 65%. How many own an HP? 35%. See, that's 100% right there, but not 100% own them, because there was overlap in there. So minus 10 would be 90%. 0.9 or 90%. All right, this next one, probability that the student does not own either a MacBook or an HP. So I'm going to show you two ways to do this. Does not own a Mac or an HP. And I showed you before, this could be 1 minus the probability of MacBook union HP. Okay, so that would just be 1 minus, or would be all of these together. So 0.55 plus 0.10 plus 0.25, which would be 1 minus, if you add all those together, you get 0.90, and that would be 10%. Okay, you can use that formula if you want. Or if you look at it this way, how many do not own either a MacBook or an HP? Those people own a MacBook or an HP. What's left? 10%. You draw the picture, you can just write that down. That's fine. But it's also nice to know this formula. The complement is 1 minus the event that it does happen. All right, print out the homework. I just did some of your homework. You do all of the problems, even the ones I did. Good luck. Have fun. Bye.